Hi class, this is Mrs. Cornett and I'm going to work through a few problems from your section 8.1 WebAssign homework. This question's talking about reading a two-way table. It says the following two-way table represents the results of scores from an exam worth 100 points. As you can see, it's broken down into two different types of students. You have your non-majors and then you have your math majors. It's also divided into the score that those students received on that test. That's why it's called a two-way table. And so now we're just going to answer a few questions about the table. Question A says how many non-math majors took the exam? We need to add 4, 6, 3, 12, 6, and 1 together. And once you add all of those non-math majors together, you have 32. Question B, how many students scored less than 50 points? Do you see how this one just says students? It doesn't specifically say math majors or non-math majors, so we're going to count both majors and non-majors who scored less than 50, which is 4 plus 1, which is a total of 5 students scored less than 50. Question C, what percent of students taking the exam scored in the 70s? Anytime you're taking a percent, you need to find the total number first, and then you can compare it to the part. And so the first thing we need to do is add to find the total number of students. We already know from question A that the non-math majors are 32. Now let's add the math majors. 1 plus 2 plus 2, that's 5. Plus 6 is 11. Plus 13 is 24. Plus 6 is 30. When we add those 30 math majors to the 32 non-math majors, it's a total of 62. Now we can go back and answer the question. It's asking for what percent scored in the 70s. If we look at our chart, here are the 70s. 12 plus 6 students, which is 18 students. And so to answer question C, we'll take the fraction 18 out of 62 and convert that to a percent. On a calculator, 18 divided by 62, and then times that decimal times 100. And it says round to the nearest percent, which is 29. Question D, what percent of students taking the test were math majors? Okay, we already know that everyone taking the test was 62, and we know the number of math majors was 30. So take the fraction 30 over 62 and convert that into a decimal. Type in 30 over 62 in your calculator, times that decimal by 100. It does say round your answer to the nearest percent, which is a total of 48%. Okay, next question says consider the following. We have a chart here about the volume of mail handled by the post office. And this is first class, second class, third class, or other, and it's pieces in the billions. This question says sketch a circle graph for the data above. We're going to sketch a circle graph by using the percentages. I've taught you in class how to sketch both in degrees using a protractor or percents using just an estimate of what we know 25% looks like and 50% looks like. For this video, we're going to do just the percents again. In order to find out the percent of each of these types of mail, we first need to know the total. So I want you to add these 4 numbers together. You should have gotten 170.3. And now we'll go through the process of finding the percent for each of these different types of mails. 91.3 divided by 107.3, and then times that by 100. I'm going to go ahead and just round to the nearest whole number. That will make it easier. This is 54%. Okay, next, second class, 11.4 divided by 170.3 times that decimal by 100, and I'm going to round that to 7%. Next, 64.4 divided by 170.3, and that rounds to 38%. One more, 3.2 divided by 170.3 times that decimal by 100, round to the nearest whole number to get 2%. Now I'm just going to check these percents and see what they add up to. 54 plus 7 plus 38 plus 2 equals 101. That's okay that it's a little above 100. It's because we rounded up each time, and that pushes it a little over 100. Okay, so quickly, here's how we're going to sketch this. It's going to be a little hard since I'm doing this on a computer screen. We're going to do the first class section first. 50% would be straight across, but this is 54%. So we can start by going straight across and then I'm just going to make it slightly larger, label this first class, and you can go ahead and label it 54%. Okay, from here, I will do the 38% next. I do know that straight down, this would be 25 right here, but then I would need to add 13 more to get to that 38. So again, I'm just kind of eyeballing it. I'm going to say something like that. Section would be third class, and that's 38%. And then from here, with what I have left over, I have the other category at 2% and the second class at 7%. I have a note here at the very bottom that tells us a benefit of the circle graph is that it allows you to see the whole picture, but not necessarily the quantities of each category. So if we could only see a comparison of the first class mail with the other types of mail. Okay, we're going to take that same data and just quickly sketch out a bar graph. So this time we're not going to use percentages. We're going to just use the raw data given to us. But for a bar graph, we need to label the axis. The x-axis is going to be our types of mail. So I'm going to say we have first, second, third, and other. The y-axis, which is our vertical, is going to be the quantity of mail or the frequency. It's a pretty big spread from 3.2 to 9.1. I think I'm going to be pretty generous and go up by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And so this is 20, 40, 60, 80, 100. Okay, so for the first class mail, we're going to draw up to 91. And again, this is not going to be super straight, but I'll do the best I can. Second class is 11.4. Remember, bar graphs do have an empty space in between. The bars should be the same width across, and the spaces should be the same width across. Third class goes up here to 64, so we're going to go up right about there, and then other is 3.2, which is going to be really, really small. Okay, so the difference between a circle graph and a bar graph is that a bar graph, we can actually see the raw data of each category, but not necessarily how it compares to the whole picture of mail like the circle graph. Here's another two-way table, and it wants us to complete the table by filling in the marginal totals. The marginal totals are actually really easy. It's just the total of each column and each row. Okay, pretty simple. So if we look under the baseball category, we have home team wins 127 times, the visiting team wins 72. To find the marginal total, we're going to add those together to get a total of 199. For basketball, same thing. 55 plus 45 is 100. Football, 50 plus 43 is 93. Hockey, 59 plus 48 is 107. Now notice there's 3 more spaces. We're now going to get the marginal total from the number of wins that the home team got across each of these sports. So that means we will add 127 plus 55 plus 50 plus 59 to get a total number of 291. And now we're going to add up all of the wins from visiting teams across these 4. 72 plus 45 plus 43 plus 48 is 208. Now we have one more blank spot, and there's 2 ways you can find that. You can add 291 to 208, and that gives you a total of 499. But to double check yourself, you can also add straight across the sports. 199 plus 100 plus 93 plus 107 is also 499. Okay, here we have a frequency table, and we have the distances in minutes that students live from a school. And then it says make a grouped frequency table with an interval of 30 minutes for these data. And so the intervals are already listed out for us, 0 to 29, 30 to 59, and so on. And we are just going to simply use the data up in red and figure out how many go in each category. Luckily, this data is already in numerical order for us, and so it makes it pretty easy. Our first group is going to be right here. This is our 0 to 29. 1, 2, 3, 4, 5, 6, 7, 8 students. Next, our 30 to 59 is going to be this group, which is 1, 2, 3, 4, 5, 6, 7. 60 to 89 will be these 5. 90 to 119, just that one. 120 to 149 will be these 4. 150 to 179, that's 0 because it's not represented in this data. And then 180 to 209, we just have 1 for that. And so just pay attention to these kind of problems. You definitely want to make sure that the numbers are in numerical order first. Makes it a whole lot easier to complete a frequency table like this. Okay, that's all the questions I'm going to do on this video. Please let me know if you have any questions.